So today we're going to look at this rate of changes and call it a slope. Let's begin with this first example that they're showing us to get the idea going. So it says, the side view of two ramps at a local skate park are shown. So this is the side view of two ramps. So let's take a look. We have ramp A and ramp B. And one ramp measures 12 by 8 feet. The other measures 8 by 8 feet. And it says, what measurement do the ramps have in common? What measurement do they have in common? Yeah, this one on the height. They both have a height of 8. Okay? So maybe we could call it vertical distance or the height. Height is 8 feet. So the difference is going to be here. Yeah, the horizontal distance. Yeah, width maybe. Yeah, let's go with width. What measurement is different between the two ramps? So ramp A is 12 feet long. Width is easier to spell and shorter. Ramp B, 8 feet. Width.
Is it length or width?
It doesn't, as long as you call one something, the other one could be called the width. So if we're using height and width, we could do that. Because one might argue that this length that we're going to call the hypotenuse when we get into our geometry portion, we could call that the length. So we don't want to get into those. Okay. So which ramp appears steeper? Justify your answer if you can, using A and B. Which one looks like it's steeper? Ramp B looks like, higher up. Steeper. So ramp B, I would agree. Ramp B appears steeper. Just by looking at it. Does everyone understand what it means when we say steeper?
Yeah, like more
inclined, yeah. More. Okay.
It goes like more higher.
Exactly. Even though they go the same height, right? But it looks like it's higher.
Like if you were to elongate it, it would go higher.
Yeah. The fact that width is shorter makes it look steeper. Doesn't it? So let's put that. The fact that it is how many feet shorter is it in that width? 4 feet. 4 feet shorter makes it look steeper. And we're going to have a reason for that, a numerical reason for that in a little bit. So we're just looking at the phenomenon of slope. Two things that go up the same height, but one is appearing to be steeper than the other one. Okay? So let's learn about this concept called slope. Um, so it's, as I keep on saying, it's kind of a big deal. We're gonna definitely look at it this school year and a whole lot next year. So when a linear relationship, I'm reading here now, when a linear relationship is graphed, the slope is a value used to describe the steepness. Let's write the word steepness here. Of the line. So now we're going to put some math and numbers into this. The slope is a ratio of the vertical change that height that we were looking at compared to the horizontal change. Horizontal change. Horizontal. Horizontal change. Or this isn't, we're going to keep on using this over and over again. Rise over run. Have you ever heard this before? Rise over run? Okay, so what it is, it's the change in the height, in the vertical change, over the change in the horizontal change. So we're going to look how much it changes going up or down versus how much it changes going across. Okay? So we call it rise over run. Rise over run. We keep on saying it. Rise over run. It's going to sound like I'm just going to say it a lot. And probably you will too. Slope is equal to the rate of change. And when it's linear, it's a constant rate of change of the graph and the linear relationship. Okay. So there's 4 types of slope we need to know about. Slope is basically going to be a number. We're going to take 2 numbers, make it a fraction, simplify the fraction, and if it's improper, we're going to leave it improper. We're not going to change it into 4 1/2 or negative 4 1/2. We're going to keep it as 9 over 2, okay, or negative 9 over 2 if it's improper. But it's basically a number, and that number is going to mean something. So here's what that number is going to mean. It can mean one of 4 things, and it's the types of slope. So we can have a positive slope. So it's possible to have a positive slope. And that means the slope increases from left to right. So your line, if your slope number turns out to be a positive number, that means your line goes uphill from left to right. Okay? So it's possible, if you have a positive, what's its counterpart? Negative. It's possible to have a negative slope. And if we have a negative slope, it decreases from left to right. So it goes downhill. Okay? So our lines are either going uphill, left to right, or downhill, left to right. And that slope would be either positive or negative. Well, what's directly between the positive numbers and the negative numbers? 0. It's possible to have a 0 slope. And a 0 slope means you have a horizontal line. A line that's perfectly flat. Okay? So if your line is perfectly horizontal, parallel to the x-axis and going through the y-axis, like that one, it's a 0 slope. Now the last one's going to be a little tricky. What kind of line would you say this is? It's a vertical line, a straight vertical line, going straight up and down. And if you have a perfectly vertical line, parallel to the y-axis, going through the x-axis. This is called an undefined slope. Undefined slope. So those are the 4 types of slopes we can have: positive, negative, zero, and undefined. Okay. So all we're going to be doing today is looking at lines using this technique called rise over run, and we're going to get a number from that. And the number would be either positive, negative, zero, or undefined. Undefined means zero in the denominator. In fact, we should probably write that down. Let's fit this in. For zero, we're going to say zero in the numerator. Zero in the numerator. And zero dividing anything, zero dividing anything is zero. So that's how we get a zero slope. Undefined is you have a zero in the denominator. Zero in the denominator. In the bottom number. Oh, I just fit it in. So you either have a zero in the numerator, it's a zero slope. Zero in the denominator, it's an undefined slope. Okay? All right. Let's go through the process that we're going to use to find this slope graphically. So follow the steps described below to find the slope of the changed line. Okay, so we're going to practice on this line, but first we're going to write the information here. So what we're going to do is we're going to choose 2 points. Choose 2 points on the graph. Then we're going to draw a right triangle to count the rise and the run. Between the points. Then you're going to set up the ratio of rise over run. So the ratio of rise over run. And you're going to simplify it. Okay? So then you're going to double check if the graph is positive or negative. Like this line that we have here, I can already tell you for sure what kind of number it should be. It should be a positive number. How do I know that it should be a positive slope? It increases from left to right. It's going uphill. Come on, Zach, don't fall asleep on me. Okay, so let's do this process. We're going to pick 2 points. So this is the part that, it's the only part that you have to really be careful. And you can only pick certain points. Like for example, I cannot pick this point here. You see how this location is between 2 of these? Yeah, you want to pick where 2 is. You want to pick where it crosses perfectly. You want to know for sure it's going through a integer location, and that happens like here. Okay? And then we'll pick another one. Say this one here. You see how I picked those 2 points? So you pick 2 points where it crosses perfectly. Now, let's do the rise over run. I like to do the rise first. So I always pick the point furthest to the left. I always pick the point furthest to the left. I'm going to start here. I'm going to go up or down. In this case, I have to go up because I want to make it to this point. So I'm going to rise. And I'm going to count how many spaces I went up. So we're counting by one. So how many spaces? I went from 2 to 6. 4. I went up 4 spaces, and they're positive because I went up. If I would have gone down, that would have been negative. So now I need to run. I need to go to the right. And moving to the right is positive. Moving to the left is negative. So how many spaces did I go over? 2. So my rise was 4. My run was 2. And my slope is 4, the rise number, over 2, the run number. And that simplifies to, 2 over 1, or just 2. So the slope is 2. And if you think about it, look, if you're at any point on the line, you go up 2 spaces and across 1 space, don't you fall back on the line? So the steepness is 2 over 1, or 2. Yes?
Couldn't you just divide the y point by the x point?
Yeah.
Like, let's just say. Like,
well, yes, and that would only work when, remember we were talking about if it was proportional?
Yeah.
Because it's proportional, that would work. If it's not proportional, it wouldn't work. So in this graph, because it's proportional, it goes through 0, that would work. But a lot of times these graphs won't be proportional. So that's why we do want to do rise over run. I think they just wanted to pick the easiest possibility for you to start with. All right, so let's practice with the other ones, okay, guys? All right. Jasmine, focus here. Put away your phone if you have it. All right. So before we even start, let's try number 1. Positive, negative, 0, or undefined. What do we got? We should have a negative. Okay. Let's. Well, we should have negative. That's our prediction. Just before you do anything, we'll have our prediction that it should be negative, and let's verify it here. So let's pick a couple of points. I'm going to pick this point here, and maybe this point here. I'm just picking some points. Again, start with a point furthest to the left. You ready, guys? Over here. Isaiah, focus on this. Come on. Now, we're going to start with this point furthest to the left. To get to the other point, do I have to go up or down?
Down.
So we're going to go down, looks like 2 spots. So this time we went down. That's negative 2 for the rise. Now let's do the run. I'm going to the right. How many spots? 1, 2, 3, 4. So the run is positive 4. So now let's write it as a rise over a run. That would be negative 2 over 4. Yeah, you have to reduce it. So we can divide by 2. Negative 1/2. So the steepness is negative 1/2, and that's the negative slope, so it's going downhill. You go down 1, across 2, down 1, across 2, you're back on the line. Okay? Now, what's our prediction for number 2? 0 slope. It's a horizontal line. And let's prove it right now. Look, we'll pick 2 points. Any 2 points. I'll pick those 2 points. Okay? So, what's my rise? If I want to go from 1 point to the next, how much do I go up or down? 0. So I'm just going to write it here. Rise is 0. And then my run, I'll just go this way, is 4. Right? So I would have 0 over 4, which is just 0. And that's going to happen for any horizontal line. Okay? All right. So I'd like you to try number 3. Try number 3 on your own. Okay, so this is what I got, guys. I picked this point at 0.3 and this point at 3.21. So my rise was 18, my run was 3, and I reduced that to 6 ones or just 6. So in the end, we all should have gotten the answer of 6. Okay. All right, great job. Okay. Let's take a look at a few more. Let's try this one together. We should get a positive slope, right? Positive. Let's pick this point. I'll pick this point here at -2, -6. And what's another good point to pick? Oh, how about right on this point here? Would that work? I'm going to pick those 2 points. And we're counting by ones, looks like. So if my rise, again, you always want to pick the point furthest to the left, which is this point, which means I'm going to go up. 1, 2, 3. And I'm going to go to the right 2. So what's my rise over run? What over what? Is it 2 over 3 or 3 over 2? 3 over 2. I like that one. Why do I like it? I don't have to reduce. We do not write this as 1 1/2, guys. Yeah, we want to keep the ratio intact. Yes. The numbers mean something here. They mean we go up 3 over 2, up 3 over 2. So if you get 3 halves, leave it as 3 halves. I know we've been trained that you see an improper fraction, you got to change it to mixed number. Not in this case. You want to leave it that way. Okay? You could simplify it. You could reduce it to lowest terms, but don't change it to a mixed number. That's all. Okay? All right. Let's get the last few and then we'll be done. Let's do this one. So I'd like you to try that one. Pick the same points I did. Predict positive, negative, or positive, negative, 0, or undefined. We didn't get an undefined one from what I can see. So what's it going to be? Positive, negative, 0, undefined. Positive, going uphill, left to right. But see, this one's not very steep. The line is not very steep.
Goes up by 2.
Yeah. So if I go up 1 step, how much did I go up? 2. And then if I go across, well, let's see, 1, 2, 3, 4. Yeah, it's 2 over 4, which is 1/2.
And you always simplify it?
Yes. You always simplify it. Okay. So 1/2. The other one was 3/2, so that's clearly more steeper. It's a bigger number. The bigger the number, the steeper the line. Let's do number 6. Pick some points. I'll pick this point and this point. What should we get? Positive, negative, 0, or undefined? Negative. Left to right, it's going downhill, so definitely negative. So if I pick the point furthest to the left, you always want to pick the point furthest to the left if you can, and you should always be able to. Yeah, we're going to go down 5. Is it 5? Yeah, down 4, right? We went from +1 to -3, so that's -4. And then how many across did we go? 3, +3. So it's -4 thirds. Yeah, you can't simplify it, so just leave it as -4 thirds. And we don't change that to -1 and 1/3, of course, right? Okay. So the next two questions are to see if how well we understood this, guys. So help me out, please. Question number 7. Luis thinks the slope is 1/2. Explain his mistake and give the correct slope. So why would he think it's 1/2? It looks like 1/2, right? Look, up one space over two spaces. Didn't he go up one space and across two? So it's 1/2. Maybe he's right. Yes. Yeah. This is actually 5. One space equals 5, and he went across actually 2. So what would we explain there? What did he do? What was his mistake?
Luis forgot to count by 5 as shown.
Yeah. Luis forgot to count by 5s on the which axis, X or Y? Y axis. So the slope is actually 5/2, 5/2. Okay. I'll finish this up with this one. The graph shows the linear relationship between number of bagels a bagel shop has remaining and the number of customers served so far that day. Find the rate of change. Rate of change is the slope. So they're asking for the rate of change, which is the slope, of the bagels remaining with respect to the number of customers served. Okay, so let's do this. So if we want the rate of change, we want to figure out the slope. And we're measuring number of bagels remaining to the number of customers. Okay. So we went from 200 to 150. We dropped how many? So it's -50 because we went down. That's -50. And then we went from 20. We went from 10 to 20. 10. Right? We went from 10 to 20. So it's -50 bagels remaining. Bagels for every 10 customers. Well, it's -5 though. -5 bagels per customer. So every time they get a customer, how many bagels do they lose? Yeah, 5. So 5. The lose is the negative, the implication of the negative. So basically, you could say every customer on average buys 5 bagels. It averages out to that. Okay, guys. I'll get the glue sticks out in a little bit.